Hi, welcome to the process improvement used in quality tools, presented by Dr. Lalis Senani, Management System Trainers. Let's first understand the meaning of a process as indicated in ISO 9001 2015 International Standard. It indicates process means set of interrelated or interacting activities which transforms inputs into outputs. What do you mean by interrelated? That means connected activities. Or interacting. Interacting means effect on each other. So the activities which have an effect on each other or connected activities that transforms inputs into outputs is defined as a process. If you look at this slide, you can see the interpretation of the process in a pictorial manner. For a process, we need inputs, and that inputs, after interacting, and it converts to an output. What are the inputs we require? Man, machine, material, methods, and information. So the most important thing that we need to remember is when we consider these inputs for a process, all these inputs should be under control. For that, the requisite requirements with respect to machines, materials, methods, and information, and also the required procedures and instructions, as far as the man is concerned, and his competency and his knowledge is very vital things as part of the control activities are concerned. If we control these inputs, definitely output will be under control. Nowadays, a popular approach is process approach. So let's try to understand what do you mean by process approach. It indicates systematically identify and manage the processes employed to ensure product conformity. So we need to identify systematically how the organization processes are arranged and how those processes we are going to manage for what? At the end of the day, to ensure that the product is in conformance with the specific standard. So normally this can be shown by producing a process map of company business activities, identifying different processes they undertake and their relationship with one another. This is how we can do in a practical form to show that these are our processes. Moreover, process approach enables an organization to plan its processes and their interactions. So when we draw the process map, it shows us how the processes are integrated or interrelated or connected each other, and then we can identify what type of controls we need to apply for each processes. If we look at this slide, you can see process A has an output and it goes as an input to process B. Normally, this is what you can see when we develop a process map. It is a very complicated one. Here I am showing a small part how the processes are interconnected. And the most important thing we need to understand is when process A output, to get that output, we have to control process A inputs as I explained. So if we have not taken any action to control the process A inputs properly, then what will happen? Process output of the process A will be out of control. Then what happens? Then that output you can see here goes as an input to process B. Then the process B input becomes out of order, and hence the process B output will go as an out of order. So then this particular system will continue right throughout the processes. It has a multiple effect, and as a result, at the end of the day, the final product will not meet the specific standard, creating waste or creating defects. Therefore, the most important principle that we need to learn is, since processes are interrelated and interconnected, we need to ensure each process output and input principle are properly controlled, because one process output will become another process input. Unless and until we understand this principle and then take appropriate action to control inputs and outputs within the organization, it is not possible to control the generation of defects or waste. Now, in order to discuss the process improvement during this presentation, I have selected a simple chart called Pareto chart. So this Pareto chart was introduced by an Italian economist. What he noted was 20% of the Italian population owned by 80% of Italy's wealth. This indicates that few people control the total population. Then this became a very popular one and introduced as 80-20 theory. Later on, this was applied in the industrial context to solve industrial issues, and with a slight modified introduction as vital few and trivial many. Vital few is the 20%, trivial many is the 80%. The importance of this tool is this can be used to initiate actions after identifying the vital or significant problematic areas, and then take actions to minimize or eliminate those problematic areas by using a scientific approach. So therefore, during this presentation, I'm going to explain you how we can use this tool to show to get a process improvement with the application of this particular tool. So let's take an example. A porcelain factory secondary data for the last 2 months were reviewed, because every day any factory, they record the relevant data of the production line, production process, where they maintain such records. So from the data, specifically, we have focused to determine the defects that has taken place during the last 2 months period. And those data were collected and collected, and those data were collected and used in the particular sheet shown in the next slide. So you can see that this data sheet, here we have collected last 2 months data. We can see the defect categories. One is deform edges, degraded color, flaking, cracks, scratches. So on the other side, it indicates the number of times these defects were occurred during the last 2 months period that we identified as the frequency. So the deform edges were occurred 10 times during the last 2 months period. So now in order to introduce Pareto chart principle, we need to change the data sheet and order it as shown in this slide. You can see we have rearranged the data sheet starting from the highest value of defects and go to the lowest one. In other words, descend in order, we have to rearrange the data sheet. We call is order the data sheet. See, we order the data sheet starting from deform edges, that is the highest one, then the next highest 26 degraded color, and like that going to the lowest one scratches. Now in order to apply this tool, this data sheet needs to be further expanded by developing another 2 columns. Let's see the next slide. So in this slide, as I told you, we do have additional 2 columns. That 2 columns we need to fulfill. How we are going to fulfill that 2 columns? So in these 2 columns, one is percentage of overall total, other one is cumulative percentage. In order to fill this column, how do we calculate the values? We go to this column, we have the 40, then this value divided by the overall total 112 into 100 is this value 35.71. Then we go to the next value to be calculated, we go to 26 divided by 112 will give us 23.21. Then if we go to the next value, how do we calculate this? In the same manner, 20 divided by 112 into 100 is 17.86. Then we go to the next column. How do we calculate these values? First, the first one we take as it is 35.71. To get the next value 58.92, we take 35.71 and that value add to this value 23.21 and then put it here as 58.92. Then to get this value 58.92 will be added to 17.86 and get this value. So that is how this column will be calculated. So now I have explained how to calculate this column, how to calculate this column. Now we are ready. But in order to make our Pareto chart, we identify each defect like this in abbreviated form. That is easy for us. A is deform edges, B is degraded color, C is flaking, D is cracked, E is scratches. Now we using this chart, this data sheet, using this data sheet, we can draw our Pareto chart. In order to draw the Pareto chart, there is a methodology that we need to follow. We have to first identify the vertical axis. So left hand side, one vertical axis is there that will be identified from a scale 0 to overall total. In our case, overall total was 112, if you remember. Then vertical axis, not only left hand side we do have in Pareto chart, we have a right hand side vertical axis also. That we will mark with a scale of 0 to 100%. In order to draw that, in order to develop the scale for this right hand side vertical axis, what we consider is 100% we consider as equal to overall total. So the overall total and the 100% when we equate based on that, we can get the scale for the right hand vertical side. Then the horizontal axis of the Pareto chart, we identify the defects or the mistakes. So that is the methodology that we are going to use to develop the Pareto chart. Let's look at the next slide. Now you can see on the left hand side, scale 0 to 112, left hand vertical scale, vertical axis. The scale is go to 112 overall total and 0 to 112. And that denotes number of defective units, that axis. This axis, x-axis, our defects we label. The first defects is A, the height of the defects, the height of this bar is the height of this bar denote that defects. The height of this bar should be 40, that is the frequency of that defects. Therefore, we draw a bar chart, we draw a bar having that height. Then the next bar should have a height of 26 because that is the frequency of that defect. Third one, the frequency of that defect is 20, therefore the height of this bar should be 20. Like that we develop this bar chart, bars, and at the end of the day, once we develop these bars, we will have the Pareto chart, but it is not the complete chart. To make this chart a complete one, we need to do the right hand side vertical axis and the cumulative frequency graph. In order to do that, we come to the end of this bar and draw a vertical axis as the right hand side vertical axis or with the percentage values. Let's look at the next slide. If you look at this slide, here you can see the right hand side we have the vertical axis with percentages, cumulative percentages. So to get the scale of this axis, what we do is here 100 we equate to 112. So once we equivalent to that, accordingly we can get the what you call the scale of this axis. Now to complete this, we need to draw the cumulative frequency graph. How do we do that? We go to the first point, first bar, this bar, we go to the edge of this point. And here, the value when we draw horizontally to here, it should be the frequency, cumulative frequency value given in the table. If we draw a horizontal line here, the reading should be 35.71, because here the cumulative frequency of A is 35.71. Then we draw from there a line, straight line, until it come to the end of this bar, this edge. And if you go to that point here and draw horizontally here, we will come to here. So the here value is 58.92 as shown in the table, our data sheet table. As shown in the data sheet table, it should be 58.92. Then from this point, we draw this line till end of this point. When we put a horizontal line, this should be 76.8 as shown in the our table. Like that, from there we go to this line, it is end from here, and when we draw this, it should read that value, table value. And then from there we go to this and end up with 100, because at the end of the last one the value is 100. So then this is called cumulative graph. And the beauty of this, now we can see that the defect A, defect B, defect C contribute 76.8 for the overall defect. 76.8% out of 100. That means close to 80%. 80% were contributed by these three defects. Vital few. So if we are really keen to reduce in a significant manner the defects generation in our factory, we need to focus the improvement of these areas A, B and C related defects areas we need to improve. In other words, deformages, degraded color and flaking areas are very much important to provide our attention in order to bring down the defects in a significant manner, which will help to save a lot of money, and then the company will become very competitive in the markets. So in order to do that, we can't simultaneously take action for these three ones. If possible, it is better, but in practical way, sometimes it is not possible. Therefore, we focus to this process first, this defect related process. How this, which processes are contributing to this defect, and then we take action to improve the related processes which creates this particular defect, and then implement that action. And after implementing, we wait minimum 3 months to see the effectiveness. After 3 months, we again collect the data as explained previously, and then again calculated the values, percentage values and the cumulative frequency, and draw the new Pareto chart in front of this Pareto chart so that we can compare and see whether our corrective action has produced results or not. Let's look at the next slide. This shows this is the previous situation. Initially we did our Pareto chart. Then after taking actions for A, then this shows the improvement chart. Here you can see the improvement chart. Once we look at this, we can see the defect A related action we have implemented, now that has become an insignificant one. You can see here, very insignificant. Earlier it is the most significant one. But now you can see it still B becomes significant now. And also you can see C also become insignificant with our action. However, earlier A was at this level. Now with our corrective action, it has come down to this level. This is the level. Therefore, this amount is the improvement that we have got with the implementation of our corrective action. Hence, we can say that our corrective action is result oriented or very effective. If we are really keen to submit a report to our management, then we have to translate this to language of money. In order to do that, we can find out what is the exact reduction of defects. Then for that you can read this value. What is the value here? And earlier it was 40. Then the balance you can calculate by taking this value 40 and reducing this value from 40. So this part is the improvement part. Maybe for 1000 items, maybe for 10,000 items manufactured, this is the reduction. So then per item value we know, then we can convert it to rupee terms or dollar terms. Then that can be submitted to the top management in order to convince them the importance of taking corrective action and the use of proper tools to get the results in a scientific manner, in an objective manner. So this is how we can use a simple chart like Pareto to improve our processes. With that, I have come to the end of my presentation. Thank you very much for watching this video. If you are really keen to obtain our services, you may please contact us. Our telephone numbers are shown in this slide. Mobile line 077 552 8728 and landline 011 272 5087, and our email also is shown here. We conduct online training programs. Also, we undertake to conduct programs at the site, following the rules and regulations given by the Ministry of Health in view of the COVID-19 pandemic. So, let's meet once again with another short training program. Thank you very much.